This lesson is on applications that connect us to rationals and polynomials. The three big applications here are work problems, distance, rate, and time problems, and mixture problems. All right, we're going to start with a rational application, and that has to do with work. All of these questions first start with identifying the type of question it is, understanding the structure, and then be able to solve it once you've done the structure of the equation. So, working together, Julia and Ashley can sweep a porch in 6 minutes. Had she done it alone, it would have taken Ashley 10 minutes. How long would it take Julia to do it alone? So we read it, get a sense of it. Second part, we break it down. So working together, it would take 6 minutes to finish a job. If she did it alone, it would have taken Ashley 10 minutes. And my question is, how long would it take Julia to do it alone? So, if it takes 6 minutes doing it together, then we need to break that down as a rate. How much of the job gets done per minute? So together, the job gets done, 1/6 of the job gets done per minute if it takes 6 minutes. And ultimately, if you do the reciprocal, you'll find out the rate, and that's ultimately what I'm doing. 10 minutes, that's Ashley. So what fraction of the job, what's the rate? So 1/10 of the job is being done per minute until the entire job. Again, if we do the reciprocal, we can get that number. And then the question is, Julia, well, I don't know. So again, the reciprocal is going to give me the rate. I don't know, I keep writing down jab. And that's what I'm looking for. So if we break it down, we have Ashley take the rate. What I don't know, which is Julia, take the rate. And then together will give me the answer, which is 1/6. So I take the rate individually, add them up, and that's together what the rate is. So it's rate plus rate equals rate. So alone, alone, and then together. That's the structure of it. This is a rational equation. To solve it, we're going to make common denominators. So what number does 10 and 6 both go into evenly? That number's 30. But there's also an x. So I'm going to multiply by 3x, top and bottom. I'm going to multiply by 30, top and bottom. And then by 5x, top and bottom. I want to make common denominators. Now each denominator is 30x. So just the numerators, I make sure I have enough room for all the questions. I have 3x plus 30 is equal to 5x. That's what I'm going to solve. I'm going to subtract 3x to the other side. So 5 subtract 3, and then I'm going to divide by 2. So x again is how many minutes it would take Julia to do the job working alone. So how long would it take Julia to do the job working alone? Julia would take 15 minutes to sweep the porch alone. All right, number 1 is done. All right, on to number 2. Amy can tar a roof. That's impressive. I can't. One day her friend John helped her. It only took 5 hours. How long would it take John to do it alone? So again, we're going to break it down. So together, it took them 5 hours. So as a rate, that's 1/5 of the job per hour. The other number is 8. That's together. So the rate is 1/8 of the job is being done per hour. That's just Amy by herself. And then my unknown is x, right? How long it would take for John to do it by themselves. So that's breaking down, understanding the type of question, and breaking down the numbers we need. The structure, alone, so Amy alone, the rate, John alone, the rate, and then it's equal to the together rate, which is 1/5. And now we need common denominators and then solve it. So 8 and 5 go into 40. but we also need an x. So 5x will make that 40x. This needs to be 40, and the last one needs to be 8x, so that we have common denominators. Now, only the numerators, so that's 5x plus 40 equals 8x, and then solve it. So we're going to subtract 5x. So 8 subtract 5 is 3x, then divide by 3. Now 3 doesn't go into 40 evenly, but it's really close to 13. So 3 times 13 is 39. So approximately how long would it take John to do it alone? In about 13 hours. All right, number 3. It takes Amy 9 hours again to tar a roof. We're back to this. Perry can tar the same roof in 16 hours. If they work together, so my unknown is together, how long would it take them? So if it takes Amy 9 hours, the rate is 1/9. If it takes Perry 16 hours, the rate is 1 over 16. And then together, the rate that I'm looking for, the unknown, would be 1 over x. Common denominators for 9 and 16 would be 144. So I need to multiply by 16x, and I need to multiply by 9x, and I need to multiply by 144. So we have common denominators. So that gives me 16x plus 9x is equal to 144. That's 25. And then when I divide by 25, it doesn't go in evenly, but it's approximately 6. So 6 times 25 is 150. So it's a little bit less than 6. But it's okay to estimate to have a sense of the problem. So if they work together, how long would it take them? So it would take about 6 hours to tar the roof together. Now that we understand the structure, we can go right to the equation. Number 4, working together, Molly and Scott can pick 40 bushels of apples in 4 hours. So that's together. That's the key word, in 4 hours. Had he done it alone, it would have taken Scott 9 hours. And the question is, how long would it take Molly? So I start with the alone part. And so Scott can do it alone, takes 9 hours. So the rate is 1/9. And my question is asking, how long would it take Molly to do it alone? That's my unknown, the rate. And then together 4, so as a rate, that would be 1/4. 36 is the common denominator, so I need to multiply by 4x. I need to multiply by 36. And I need to multiply by 9x. So just the numerators, 4x plus 36 equals 9x. Subtract 4, that's 5. Divide by 5, and the answer is about 7. So 5 times 7 is 35, so it's close to that. And then the sentence. It would take Molly 7 hours to pick 40 bushels of apples working alone. A good solid sentence at the end. So we have a sentence that answers the question and respects the story. The answer is 7, answers the question, but doesn't respect the story of where it comes from. This has to be in context. Number 5. Working together, Shayna and Cody can harvest a field in 7 hours. That's together. That's the key word. Had he done it alone, it would have taken Cody 13 hours, and I want to know how long it would take Shayna working alone. So we break it down to understand it. So alone, the rate for Cody, and the unknown, and then together. So 13 times 7 is 91. I'm going to tell you that right now. That's 7x. That's 91. And that's what? 9x. No, 13x, sorry. So now we have common denominators. We have 7x times 1, 9d1 times 1, and 13x times 1. Subtract 7, and then divide. So 91 divided by 6 is about 15. And so how long would it take Shana to do alone? It would take, let's see if I have room here. It would take Shana 15 hours to harvest a field alone. There we go. Number 6, Shanice can sweep a porch in 12 minutes. Willie can sweep the same porch in 13 minutes. If they work together, that's my, how long would it take them? So that's my unknown. So Shanice, the rate. Willie, the rate. And then alone, and there you have it. And then we're going to solve that. So 12 times 13 is 156. So this is going to be 13x. This is going to be 12x. And again, 13 times 12 is 156. So this is 13x plus 12x equals 156. Because these numbers are very close, their rate is very similar. If you find the average in terms of that, if they work together, then half of that would take away the time anyway. So the answer is going to be close to working about 6, right? So if they both take about 12 hours alone, when they work together, it would take half the time, right, to finish the job, just logically speaking. So we're going to divide by 25, and yet the answer is about 6. So it's a little more than 6, but it's close to 6. So it would take 6 minutes, not hours, to sweep the porch together. All right, turn the page. Now these questions, we need to recognize this is no longer a work question. Daniel left the mall and traveled east at an average speed of 45 kilometers per hour. Dan left 2 hours later. I'm glad we have Daniel and Dan, 2 different people. Left 2 hours later and traveled in the same direction, but with an average speed of 75 kilometers per hour. Find the number of hours Daniel traveled before Dan caught up. So Dan left the mall and traveled east at an average speed of 45 kilometers an hour. Dan left 2 hours later, traveled in the same direction. So if this said west, that's what would matter. Maybe it would say north or south. Direction, but with an average speed of 75. And then my question is, find the number of hours Daniel traveled before Dan caught up. Okay. So this is a question that relates distance and rate and time. So this requires this formula to know by heart. Distance is equal to rate times time. Sometimes we remember it by saying the word dirt and then taking out the word I and making it an equal sign. And so we talk about this being like a dirt question. So if I say the word dirt and take out the I and make it equals, it reminds me of that formula. I'm going to create a bit of a chart to organize the information because we have 2 people here. Now, the first person is Daniel, and the second person is Dan. And then I'm going to read and fill in this chart. So, Daniel left the mall, traveled east at a rate of 45 kilometers per hour. That's rate, speed. So I know how fast Daniel's going. Daniel left 2 hours later. Dan left 2 hours later. So we have to think through this. I don't know the time for here, but I know Daniel has traveled for 2 more hours than Dan because Daniel got a head start. So Daniel's been driving for 2 more hours if I'm a good reader. So whatever the time Dan has gone, you have to add 2 to Daniel because Daniel has a head start of 2 hours, if I read it carefully. And Dan is going 75 miles per hour. And find the number of hours until Daniel catches up to Dan. So that means the distance is the same for both. So I don't know what the distance is, but whatever that number is, it's equal because one is caught up to the other. So the top line is an equation. Distance is equal to rate times time. And the bottom row is also an equation. And that's distance is equal to 75 times x, rate times time. Notice we have a little system here, two equations, two unknowns. They're both equal to d, so then I can just make them equal to each other and solve it. So there's one equation, and there's the other equation. And now I need to have the skill to solve that. So I'm going to distribute. I'm going to subtract 45. 70 subtract 45. 75 subtract 45 is 30. And then divide, and you can see the answer is 3. Now x represents how many hours Dan was on the road. So Dan was on the road for 3 hours before he caught up to Daniel. Find the number of hours Daniel traveled. So if I want to know what Daniel traveled, then to that answer, I need to add 2. So Daniel is x plus 2. X is 3. So 3 plus 2, how many hours was Daniel on the road? And we have our answer. So Daniel Daniel traveled, let's use the words that's in the question. Daniel traveled for 5 hours before Dan caught up. All right, let's try the next one, number 8. James made a trip to the lake and back. The trip there took 3 hours, and the trip back took 2 hours. He averaged 15 kilometers an hour faster on the return trip than on the outbound. Outbound means the in. Outbound means the first part, the there part, compared to the return. So as you go out or come back in. Find James's average speed on the outbound. So that's the first trip there, not the trip back. This is a dirt problem that we're going to organize together. So in this case, we don't have two different people. We have the trip there. Now they call it the outbound, so I'm going to call the trip out there and then the trip back. The outback. The trip out there took 3 hours and the trip back took 2 hours. Just organizing the information. He averaged 15 kilometers an hour faster on the return trip. So this back is really the return. So however fast he was going, he went 15 kilometers faster on the return trip. And then because you're going there and back, the distance is exactly the same. So the distance going to somewhere and then returning, the distance is the same. So we have one equation, d equals r times t, and d equals r times t, and then I'm going to solve it. Just like before, they're both equal to d, so we can make them equal to each other. And then we solve this. So I'm going to distribute. That's 2x plus 30. I'm going to subtract 2x to both sides. That's nice. When I subtract 2, I get 1x, and I have the answer, which is 30. Now, x represents the outbound. So find James's average speed on the outbound trip. We just found it, and the answer is 30 kilometers per hour. So on the outbound trip, James's average speed was 30 kilometers per hour, which is pretty slow. Must have been traffic. Number 9. A jet left Singapore and flew west at an average speed of 160 kilometers per hour. An Air Force plane left 2 hours later and flew in the same direction, but with an average speed of 240 kilometers an hour. Find the number of hours the jet flew before Air Force plane caught up. So this again is distance is equal to rate times time. I'm going to organize it with the chart. In this question, we have a jet and we have an Air Force plane. The jet is flying at a speed of 160 kilometers an hour. We know that the plane left 2 hours later. So this is the plane, and then the jet has a head start of 2 hours. So the jet has been flying for 2 more hours than the plane, and has an average speed of 240. And the question is, find the number of hours the jet flew before the Air Force plane caught up. So the distance is the same once they caught up. So one equation, distance is equal to rate times time. Distance is equal to rate times time. These are polynomial questions, tell you. Make them equal to each other because they both are equal to d. So I'm going to distribute right away. And then I'm going to solve it. So subtract 160. 240 subtract 160 is 80. Divide by 80. 32 divided by 8 is 4. The zeros divide out. And there's the answer for the plane. Now the question didn't ask for the plane, they asked for the jet. So then I have to add 2 to that answer. So how many hours has the jet been flying? And the answer is 6 hours. So the jet flew for 6 hours before the plane caught up. Number 10. Chelsea made a trip to her friend's house and back. The trip there took 4 hours and the trip back took 3 hours. Let's circle the information. What was Chelsea's average speed on the trip if she averaged 72 miles per hour on the return trip? Distance is equal to rate times time. We have the same person here, but the two trips are a trip there and a trip back. So I'll call it the trip there and the trip back. So the trip there took 4 hours and the trip back took 3 hours. She averaged 72 miles per hour on the return trip. And then the distance is the same, so my unknown is there. The distance is the same because it's there and back. So we have two equations. Now 72 times 3, I did that already, it's 216. So then we make it equal to each other and divide, and it does go in evenly, and the answer is when you divide 54. So the question is, what was Chelsea's average speed? So Chelsea's average speed was 54 miles per hour on the way there to her friend's house. All right, turn the page. Two more questions like this. An aircraft carrier left Port 47. That's just a name, not a number for our question, that not an important number, and traveled south. 7 hours later, a fishing boat left traveling 14 miles per hour faster in an effort to catch up to it. After 3 hours, so let's see what numbers do matter. 7 hours matters, 14 miles per hour matters. After 3 hours, the fishing boat finally caught up. And then the question, what was the aircraft's average speed? So this again is distance is equal to rate times time. We're going to organize it. So in this case we have an aircraft carrier and a fishing boat. Seven hours later, a fishing boat left. So the aircraft carrier has a head start of 7 hours. Traveling 14 miles per hour faster than the aircraft carrier. And then, before I get too crazy here, it says, after 3 hours, the boat finally caught up. So I actually know this. So it's not an unknown. The fishing boat took 3 hours to get caught up. So if the aircraft carrier's been out there for 7 hours, add them together, I actually know this number. This number now is 10 based on that. So fishing boat 3 hours, 7 hours later, that makes 10 hours that the aircraft carrier's been out there. Now I can understand the rate. What was the aircraft's average speed? And we know the fishing boat is going 14 miles per hour faster than the aircraft carrier. So I don't know this, but I know it's 14 more for this. And I know the distances are the same. Once they catch up to each other, they've gone the same distance. So we have distance is equal to 10 times x. Distance is equal to x plus 14 times 3. Make them equal to each other. That's 3x plus 42. Subtract 3. Divide by 7. And you get a nice answer. So what was the average aircraft carrier average speed? We found it. It's 6. And it's miles per hour. All right, one more like this, number 12. Ashley left school and drove towards the ferry office. Yay, that's a boat. Nicole left 2 hours later, driving 75 miles per hour in an effort to catch up. After driving for 3 hours, Nicole finally caught up. Find Ashley's average speed. So we have 2 hours and 3 hours. Let's just break this down again. Distance is equal to rate times time. If they caught up to each other, the distance is the same. I don't know what it is, but it's equal. Nicole left 2 hours later, and after driving for 3 hours. So, sorry, let me break this down. This is Nicole, this is Ashley. So Ashley drove for 3 hours, and Nicole left 2 hours later. Oh, sorry, Nicole went 3 hours, and Ashley left first 2 hours before that. So in other words, Ashley went 5 hours, and Nicole went 3 hours. Nicole went 75 miles an hour. It said find how fast Ashley was driving so they could catch up. So distance is equal to 75 times 3. Distance is equal to 5x. Make them equal to each other. Divide by 5. Here's a technique, maybe, if you didn't have a calculator, don't multiply this out. Divide, and then 5 goes into 75 15 times, and 15 times 3 is 45. That's another way to simplify it without a calculator, and then write a sentence. So Ashley's average speed was 45 miles per hour. All right, so those are questions to deal with distance, rate, and time. Now the last type of questions have to do with mixtures. Again, identify it's a mixture, knowing the structure and how to organize the information, and then solving the equation. All right, 7 gallons of an acid solution was mixed with 9 gallons of a 10% acid solution to make a 45% acid solution. Find the percent concentration of the first solution. So we have the first mix, we have the second mix, and then we have the end mix. So we're mixing two things together. I'm just going to call them 1 and 2. And then we have the end mix at the end. We're going to draw a chart to organize the information. For a mixture question, in this case, the two information we know is quantity and percent. So how much and the percent of how much. So quantity is how much. So for the first solution, we have 7 gallons. We don't know the percent of acid. The next one, we have 9 gallons and we know it's 10% acid. And then the end mix, I have to add these numbers together. So if I mix them together, there's now 16 gallons. And the end mix has a 45% acid solution. And this is what I'm going to solve. So I'm going to multiply the columns and then solve the equation. So that's 7x plus 90 is equal to, if you multiply, that's 720. And then solve that. So we're going to subtract 90. Divide by 7 and get our answer. So the question was find the percent concentration of the first. So the first solution was 90% acid. All right, number 14. 1 liter of a sugar solution was mixed with 3 liters of a 24%. So we have 1, we have 3. To make a 22% sugar solution, find the percent concentration of the first solution. So we have the first mix plus the second to make the end mix. So we have the first solution, the second one, and then together they make the end mix together. Again, we're going to break it down into 2 categories, and those categories are the quantity and the percent of whatever it is. In this case, it's percent of sugar. So the first solution is 1 liter. And I don't know what the percent of sugar. The second one is 3 liters. It has a 24% sugar solution. And then the end mix, we have to add these together, and it's 22% for the end mix. So we multiply, equal, and we multiply. Subtract 72 and you have your answer. So the percent concentrate. So the first solution was 16% sugar. All right, turn the page. We're almost done. 12 gallons of a saline. Saline is a fancy word for salt. Was mixed with 4 gallons of a 9% saline solution to make a 12% saline solution. Find the percent concentration of the first solution. There we go. So we mixing 2 things to make an end mix. We have the quantity and the percent. In this case, it's percent of salt. So the first solution has 12 gallons, but we don't know what the salt percent is. The next one has 4 gallons, so that means, and it has 9%. That means the end mix, I know my focus is going in now, you have to add these together when you mix them. So the end mix has 16, and it said that it has a 12% salt solution, and then I solve it. So 12x plus 36 is equal to 16 times 12 is, I did this already ahead of time, 192, and then I solve it. So subtract 36, and then divide by 12, and you get your answer. So the first solution is 13% saline. And number 16. 3 liters of a 2% sugar solution was mixed, my camera, with 6 liters of a 14% sugar solution. What's the concentration of the end mix, the mix at the end? So again, I'm just going to call it 1 and 2, like Dr. Zeus and the twins, thing 1, thing 2. Just being able to understand the type of question it is and organize it. The structure makes it much easier to solve, other than being out of focus. So the first solution is 3 liters and a 2% sugar solution. The second one is 6 liters and 14%. So add them together, we have 9, and I want to know what the end percent of the end is. So multiply, that's 60, 20, was it 84? And then multiply, and then that's what we're going to solve. So when we divide by 9, x is equal to 10. So the mixture solution is 10% sugar. All right, number 17. 6 fluid ounces of an alcohol solution was mixed with 3 fluid ounces of pure water to make a 4% alcohol solution. Find the percent concentration of the first solution. So we have thing 1, thing 2, and the end mix. We have quantity and percent. In this case, the quantity is in ounces and percent of alcohol. So alcohol solution, we don't know the first one. The second one, we have 3 fluid ounces. Now pure water has 0% alcohol, so that's why it's 0. And then the end mix, 6 plus 3 is 9. Oh, and the end part is 4%. And so how much was it to begin with when you mix it with pure water to get it down to 4%? So multiply. Now 3 times 0 is 0. So I'm not going to add 0. And then 36. Divide, and you have your answer. Super simple once you structure it. So find the percent concentration of the first solution. So the first solution was 6% acid. No, not acid. Alcohol. Last one. For his birthday, Ted mixed together 8 gallons of brand A and 2 gallons of brand B. Brand A contains 20% fruit. Brand B contains 35% fruit. What percent of the mix at the end is fruit juice? So in this case, I'm just going to call it A and B because of the brand, and then the end mix. Though you can still call it 1 and 2. It's all good. So we have quantity and percent. So first, brand A, we have 8 gallons, and it is, and 2 gallons of brand B. A has 20% fruit, B has 35%, and then the end mix. So 8 plus 2, we now have 10 gallons, and we're trying to figure that out. So multiply. So this is 230, divide by 10, easy peasy. And the answer is the end mix is 23% fruit juice. That is it, my friends. Mr. G Math over and out. Till next time.